Hello everybody, Mr. G here with HSS Robotics. I'm gonna have to apologize for today's video. I've lost my voice a little bit, but we'll try and get through this together. So we're working on our PCBs. Last video, we finished making our schematic, which is this puppy right here. Now that our schematic is beautiful and we're happy with it, and we understand how the current is flowing through the circuit, pushed from the power source, like the battery, to the switches, which allow us to break and reconnect the circuit, to our load, which is the LEDs in this particular circuit. And then we flow through a resistor to make sure we're not overloading the circuit, and then back to the power source or battery. So very simple circuit, a schematic like this one here. I'll zoom in on it. Allows us to easily be able to identify components, draw it easily on a sheet. They're just symbols that help us kind of problem solve. And if you are an electrician or you're going into robotics, mechatronics, whatever, you're going to be reading these a whole lot because it takes a lot of work to draw out components beautifully like an artist. Um, but with the circuit diagram, it takes seconds. So this is our bread and butter for understanding circuits. So once we have one of these, then Fusion 360 is automatically going to create a printed circuit board. So we'll go over to that tab. You can click on the top here. And this is our printed circuit board. Let's give ourselves a bit more space. You'll notice on the printed circuit board, we already have our battery. We have our resistor. We have our RGB LED. And we have our 3 push button switches. You're like, great, we're done. But actually, there's a lot more to know. So in Fusion 360, they have some automatic settings. And our PCBs are rather rudimentary on the scale of professional to we're just making them from scratch. So we don't have professional machines. We have really nice equipment to be able to do this. But we need to change some settings to make our lives a little bit easier and so that we do things right the first time. So if we go up into the top left corner, we have switch to schematic, and we're going to keep working our way over until we get to layers. So we're going to click display layers. And on display layers, right now we have a top, bottom, pads, vias, unrouted. We got a million layers in here that are automatically set. Now, if we have a little eyeball here, we can turn layers on and off. And on the right side, wherever's green is the layer that's selected. So that's the layer that you're drawing in. So funny enough, we actually want to draw in the bottom layer. Because if you think about it, our components, like the LED and the resistors, they're sticking out the top of our circuit board. So our wiring, let me grab this guy. So our wiring actually is on the bottom. A lot of circuit board manufacturers, Arduino is a great example. If you take a look at an Arduino, they have circuits running on the top and the bottom. They're also covered with a screen to protect them. We don't have a screening machine. So we just leave ours exposed, which over time that can corrode and stuff, but it works pretty good for our purposes. But we need to make sure the bottom is selected. So select on the bottom. If you're ever drawing routes, which is this right here, how you connect your components together, if it's red, stop. It means you're in the wrong layer. So go back to the blue one. On that vein, we can just go ahead and if we click on this minus sign and then we click on the eyeball, it will turn everything off. So you won't be able to see anything except a couple little plus signs, which those I think you can just delete. Nope, you cannot. So you leave those, they're fine. We could scratch them out later. And then we could go back and turn on the bottom. We could turn on the pads. And then we can just keep looking for things we want to leave on. Pretty well by the end, we just have those. I like to turn on the outside border. I think it looks good. You want to have the unrouted so we can see that to route it. If you want all the component names and stuff, that's wonderful, but we don't really need them. Everything on this board that shows up, we're going to print and it will etch out in copper. So the less stuff we have, even these little plus signs that for some reason I couldn't delete, are annoying because they are copper that could bridge and short circuit our things. So we're going to keep everything else off except for this. So take a fine look at that. Wonderful. Okay, now we need to set the widths and dimensions of all of our copper traces. So we're going to go up to the top. There's a button here that says design. This is allowing us to draw things on our circuit. And we're going to go to document and then one more over to rules. So rules, we got a couple different buttons, but basically we're telling the program what it can and cannot do. So we're going to go first to design rules. We'll click on that button right there. It will bring up a menu. And there's a bunch of things on here, and you may not understand what a lot of these mean. And that's okay. We're gonna learn them together. There's a few that are really, really important for us to know. The first is your wire clearance. Like how wide can it be between each line? And what's great is if you click on each one, it shows you a little example. So 6 mil is not a lot. I like to have a little bit more forgiveness. And I'm going to click on this and you can either click on it there or click on it here and set that to 10. Your pad clearance. So your distance between a wire and a pad. So pad is where you solder a component to. Again, I like to do that up to at least 10 mil. Hopefully it will be more, but you don't always get the luxury. Wire to vias. So vias is where it goes through the board and up to the other side. It's like a wire goes from the bottom of the board and then it goes to the top and it continues on the top. We don't have vias because we're only working in the bottom, so that doesn't really matter. Distance between pads. We like to have as much as possible. There's some components, an RGB LED is an example of that, where the pads are close together. There's nothing we can really do about it except be good at soldering. Still, I like to have. The rest, we don't really have. SMD stands for Surface Mount Device, which we don't use here in the shop because it's a little beyond the scope of our soldering abilities with surface mount because they just sit flat and they solder in place. Let's see, the board outline. This is one I really like to set nice and big. So it's 40. I like to set it to 60. Make sure you have a nice big round edge around the outside of your board. We're gonna keep going down. Drill clearance. If you set your pads far enough away, your drill places will be far enough away. So this you don't really have to worry about so much. Now, this is the one that is crazy important. This is the width of your copper, and it has 6 mil, which is so tiny. I like to do this like as big as possible, just because when you're putting the ink onto the printed circuit board and then you etch it out, if there's any kind of bits, mistakes in the etching or in the toner transfer or in the etching process, your whole board can be ruined by the tiniest little thing, and it's a nightmare because you got to connect them somehow. So I like to set this as big as possible. We'll start with like 70 and see if it allows us to do that. So I'm gonna hit 70. So that's a huge change. Because if you look at our Arduino, they're tiny. They're really small. The wires or the copper. And that's okay for a professional setup, but we're learning how to do this for the first time. So let's keep it nice and wide. The drill size, you're going to be doing your own drilling, so that doesn't matter so much. And that's really all you need to do in here. There's a bunch of custom rules. I wouldn't worry about that too much. you kind of have to create your own rules. I think we're happy with the generals at this point. We'll click OK. Wonderful. Okay. So you may have noticed some difference already to the size of some of our pads because we made our pads a little bit larger, or like more spaced apart. Sorry. In the preferences, we are going to go to design preferences. So this is, instead of rules, this is just stuff that we would prefer to have happen if possible. There's a bunch of things in here. I want to turn your attention to annular ring. So this is when you drill through what the bottom, the top, and some circuit boards, actually most circuit boards these days, have many, many layers. And so wires can run in the middle of the board and they can go up and down through the board. It's how you can make a device like your phone work. It's so complicated and it needs so many routes and they all are overlapping. And that's the struggle we have with the overlapping. And well, you'll find out about that soon. But if you have your pads, you've got your top and your bottom. So our bottom, right now, we have a minimum of 10. That's pretty small. Let's go ahead and try and make this 70. That way, it's about the same size as our wires. So nice and big. So we'll hit that. Larger than the maximum. Make sure your maximum is larger than that. So let's do 90. Oh, 900. Oh, now if you take a look at that, we're too big, way too big. They're overlapping and we're gonna have issues. So we're gonna go back. I think I hit 900 instead of 90. Boom. Okay, let's click OK. Oh, okay. So we're still like way too big. So go back to preferences. Maybe I was getting a little too excited with making things big with 70. Let's try 40. 40 sounds good. Okay. Aha. Okay. So 40, we're getting closer. I'm still way too big. I think I bit off a little bit more than I could chew there. We're going to go to annular ring and we'll make that, let's say 30. 30 is good. Oh, okay. So 30 is pretty good. We still have some issues in terms of our RGB LED. Look at that. They're so tight together. So we're going to make another bit here. Annular ring. 20. Let's see. Oh, we're getting closer. You want those to not be able to touch, but we need our pads as big as possible because that's what we're soldering to. So 20, let's do 16, and we'll do our largest at like 30. Oh, did 3. Oh, still too close. You remember those rules we set before? They need to be a certain distance apart. It's not a lot, but just enough where they've got a little bit of an issue right there. So we're close. We're close. Very close. We're going to go back. 16. Let's try and do it. 14. Okay. Ooh. See, now here, I like this. I think that is a more than appropriate size to me. However, it's kind of, what's the word for it? It affects our rules. We need to go back and change our rules. We need to allow the pads to be closer together if we like this. I'm also looking at our drill size and I find it's quite large. So we can go back to our design rules. And if we go to, I'm going to change our drill size first because we're drilling ourselves and I want as much copper as possible. So I'm going to call this is going to be maybe 6 mil. We'll click 6 mil. Click OK. Did anything change? Did it? Maybe it didn't. Okay. Go. Rules. Back to design rules. And you can just fiddle with this until it feels right. There's no right or wrong answer. There's just boards that don't work and boards that do. So, wire drill size. Oh, it's going to preferred. Let's see. Let's do the preferred 6 mil as well. Okay. Copper width, happy with for now. Might be a bit big. We might have to go back. And then I had pad to pad clearance. Here we go. So let's dumb this down to 6 mil. And we'll click. Oh, and look, that blues went away. That's looking really good. Yeah, so we'll go back into our preferences. And I wonder if it has anything about the drill itself. Shapes, apply, masks. No, not really. Okay. Well, I think I'm pretty happy with that. There's also a button called layer stack. I don't know the difference between those two because they look the same to me. Layer stack versus preferences. So I'm pretty happy. Okay, now that we've set our rules, we're on to actually like wiring things together. So all of these yellow wires here, what do? They are the pathways that we can connect things together. And you notice they're all cross. And what do we know about electricity? It can't cross, can't touch each other. It's got its direction, it's got to have the flow, and then it needs to go to its component. It can't touch another wire. So we're going to need to go back to design. So design right here. We can click on this button, which is the route button. And it gives us a whole bunch of options. And ooh, this is interesting. It wants us on middle. That works. Oh, look at that. And there's our wire. And we can bring it all the way across and it'll snap to where it wants to go. However, before we do that, this is a waste of space. And look at all these crossing wires. So we need to go, my face is in the way. We need to go to the top right corner where it says modify. And we can click move. And then we can take all this stuff and move it closer together. So this one, I don't like how it fits that way. So what I'm going to do is I'm going to rotate. And I'm going to click this guy to rotate. Ooh, I don't like that either. Rotate. Rotate. Ooh, okay. Now we can move it into place. Oof. Look at how close I can get those two. And they line up perfectly and nothing crosses. Right. Now I'm going to move this guy. Look at how twisted that is. What if I rotate it? Let's take a look at here. Hey, okay, now look at all those. They're coming apart, coming apart. So now we need our buttons to work. So we're gonna rotate this guy. And you could rotate it actually wherever you want to. But, okay, let's see if that works. Then we'll click move. Oh, we've got a cross. That's no good. Oh, we've got another cross. That's no good. And we've got another cross. Okay, so there's some things we can do. Let's try rotating. Yeah. And, oh, perfect. There's one. Two. Hey, nothing is crossing. Okay, perfect. So now we need to decide where we want things on the board. So I think I want to have one button there. I'm going to have this guy right in the middle. I'm going to have two buttons there. Ooh, I want those to line up. Why don't they line up? That's annoying. Three. Oh. I wonder if I can move it less. Grid settings. 50 mil. Let's see. If I do 10 mil. Oh, 5 mil off. Okay. Screen shares in the way. Let's see. We'll do 5 mil. Okay. Oh, I had it for a second. Right in between. There it is. Aha. Okay. Now we're all lined up. Got 1, 2, 3. I want this guy to be lined up right in the center of my button. So it looks really good. I've got my resistor and I've got my battery. Okay. that works out really good. I could probably even move this down a little bit. Easiest routing job ever. And that's what's great about a really simple circuit. So it's really fun to get it so just right on the board. At least I find that. That down a little bit more. Center it again. Oop. This down a bit. This down a bit. Things start to get pretty close, which is a good thing because we want everything to be on a nice small board. Okay, now the outside, we can bring that in as well, as long as we're in our minimum distances. There, there, there. You see if we get too close, it'll do that little blue thing. It's like, hey, do better. All right. And I like to leave enough space on one of the sides for me to write my name on the project. But there, this is beautiful. And we also want to make sure we're leaving enough space for the actual footprint of the electronic. So this, I'm getting worried about. This is actually too close. So I'm going to move that guy out. So we got a nice big circle. If you want to check, you can turn on whatever layer has all of the, nope. It's a gray one. It's this one. Nope. Which has all of the component bits in it. Let's see, drills, holes, measures. Oh, document. This one. Ooh, look at that. So see, that's how much space that one needs. All the other. So that's one. I must have missed one. But I kind of know where those are gonna be. You can kind of make an assumption, but that is what we're gonna look like. I'm just gonna move it all the way out just for safety. I can put my name right here. Okay, so now what you need to do is you need to take a route. So this is a route. So we're gonna grab a route and you're gonna follow where all of these yellow air wires are. So one is gonna come from here. That's gonna go to there. And you'll notice it actually totally dwarfs the size of my pad, which is great. More copper, the better. There's no issue with having. Okay, so now we need to go with this one to the outside. I'm actually gonna run this at. You see, it's limiting me from getting so close to the edge of my board. I can't get there. So I'm gonna run it like that. Needs to go around nice and wide. I'm actually a little bit concerned with the thickness of this copper. It's just maybe a little bit too thick. So the annoying thing is that you actually need to delete what you've done. Otherwise, you're going to have to redelete it later or rewrite it later. So I'm going to go back into my rules and I'm going to go back into my design rules and I'm going to check out that copper width and I'm maybe going to make this 60. Just a little bit much. So we'll click OK. And yeah, now we'll go back to design, route. I think that's a perfectly appropriate size here. It just can get a little bit further away from my pads because I definitely don't want those to always hit every single point as we're going along. Here's a nice little noise sound. Just wrap all those up. Straight out here. I like to side. Ooh. Ooh. So see the wire to pad clearance. Now we're running into a problem. So we need to hit escape and we're gonna go back to our rules again. And sometimes you gotta tweak these as you go. So our wire to pad clearance is 10. We need to make this maybe back to 6. We'd prefer more, but we'll just be smart about where we route. So we'll click OK. Back to design. Route from there. Ooh, it still doesn't let us. Is it that close? It might penalize us. We'll see what it says. For the most part, everything's super clean. Down. You always want nice soft corners. You don't want any harsh corners. Oh, see here it didn't quite make it into the pad, which is interesting. I want to make sure it does. So I'm going to delete those. And we'll maybe start from the pad this time. There we go. Okay. Now that you've done your routing, we can go over to this little error button. On this error button, it will tell us where all of the issues are with our board. And actually, boom, I did it so well. There's none. But if, for example, we had our rules saying, nope, too close, can't do that, it would pop up here. Let me show you an example. So if I were to wire this, aha, we have an overlap. And it will tell us, and it's like, oh no, bad things. Delete this. Okay, we could go back with our delete tool and just get rid of that silly nonsense and that silly nonsense. And we're beautiful again. Okay, I'm gonna stop this video. It's gone on for long enough. I've been just yapping on, but you should have a beautiful board like this. There's a couple last things to do, which I'll cover in our next video, but you are almost ready to print it out to etch. So that's really exciting. Congratulations. All right, catch you next time, folks. How do we stop this? How do we stop this?